Okay, now let's look at the concept of percentile rank. So percentile rank is usually assigned the variable capital K. K% of datums are strictly less than the datum of interest with the lowest rank. And it follows this equation here. And so on the right-hand side, I've kind of defined what each of the variables and the symbols mean in this formula. So R with the subscript DOI, this is the rank of the chosen datum of interest with the lowest rank. N is the total count of datums in the data set. And these symbols that kind of look like brackets. Okay, maybe you can't see it too well there, but imagine a bracket only with a bottom shelf on it like that. Okay, that's what's in this formula here. And what that means is that you're going to round down, always round down to an integer when using this formula. And so when you use this formula, you're going to end up with a percentile rank, and that percentile rank refers to the percent of datums that are strictly less than any datum of interest you choose. So for now, just kind of, we'll pass over this stuff that's in this gray shaded box and keep moving. So percentile rank will be a value between 1 and 99. Percentile ranking a data set subdivides a data set into 99 equal parts between the minimum and maximum values. So let me give you an example of that. So here we have the exam scores. These are points correct for 14 students. And you see that the lowest score was by a student named Jason. Jason scored a 69. And the maximum score was scored by Micah, and Micah scored an 83. So we have a minimum of 69 and a maximum of 83. Now, what percentile rank does is it takes this range between the minimum and the maximum, and it subdivides it into 99 equal parts. And that's kind of what you see here with each of these little rectangular gradations here. So percentile rank is a way of ranking student scores relative to students, relative to themselves. So we're going to be able to look and see how Judd's score is ranked relative to Jason and everyone else below him. We're going to look at Jin, and we're going to be able to look at Jin's score and see how Jin's score is ranked relative to everyone else. And we only care about everyone else. And so we're going to be taking a particular datum of interest and getting an associated percentile rank out of it. So let's stop talking about it and let's actually do something with it. So maybe you can see how this looks when it's applied. So given the random variable x, where x is customer age in years, and the following observations. So this is the same data set that I used earlier. So this data set has been sorted in ascending order, and each datum has also been ranked from 1 to 16 because there's a sample size of 16. Now the question we have is to calculate the percentile rank of 72. So here is 72. We want to know what its percentile rank is. So in order to calculate percentile rank, we want to use the formula that I introduced earlier. The percentile rank of the datum of interest is equal to the rank of the datum of interest divided by n plus 1 times 100, and then that will be rounded down. So our datum of interest is 72. Okay, that was here in the problem. The rank of 72 is 3. So 72 is the third datum in our data set. And n is 16 because we have a total of 16 datums in this data set. So now we need to take the rank of our datum of interest and the sample size and plug both of those two into our formula here for the rank of our datum of interest and our sample size. So here we've got the percentile rank of 72 is equal to the rank of 72 over n plus 1 times 100. And so here you can see where the rank of 72 is 3. So we've substituted the rank of 72 with the number 3. We know that n is equal to 16, so we substituted in for n the number 16. So in the numerator, here in this next step, we still have 3. 16 plus 1 is 17. And if we take 3 divided by 17 and multiply that times 100, we get 17.6 and decimal place, decimal place, decimal place. Now, this is where you want to make sure that you round down. Okay, traditional rounding rules would tell you that because this is a 6, we would round that up to 18. But in this formula, you're always going to round down. So we're going to round down to 17. So this means the percentile rank of 72 is 17. All right, so what does 17 mean? First of all, let's go ahead and put 17 here for our percentile rank. So what we've got is the percentile rank of 72 is 17, and that means 17% of the datums in the data set are less than 72. So these two other datums, 71 and 69, are part of the 17% of the total datums that are less than 72. So if we go back up here, we can see that, let's see, 72. Okay, these are students. This is a different data set, sorry. So here we had one customer that had an age of 62, and two other customers had ages of 69 and 71. So those two customers are part of this 17% of datums that are less than 72. Okay, I kind of want to skip this right now because I just want to stick to this idea. So now that you've seen an example of calculating percentile rank of a datum of interest. So here, this was our datum of interest, and we wanted to calculate percentile rank. Use this example as a model and see if you can calculate this think pair share. I've given you, the answer down here in the lower right-hand corner. So as you work on this, if you get that answer, you can probably skip the next video explanation. All right, so go ahead and pause the video here. Try it yourself and come back if you need extra help. Okay, we're back. So let's look at this think pair share. So now we're calculating the percentile rank of 77. So 77 is up here. So we want to try and calculate this value of K, percentile rank that's related to our datum of interest. So the first thing we want to do is make sure that we use our formula. first thing you want to do, just made a mistake. First thing you want to do is write down the formula. Okay, our datum of interest, 77. So the rank of our datum of interest is going to be the rank of 77, and that's equal to 14. 14, I'm sorry, 14 is the rank of 77. All right, and our sample size is 16 because we've got 16 total datums in this data set. Now we just have to substitute the rank of 77 and the sample size into our formula here. So the percentile rank of 77 is equal to the rank of 77 over n plus 1 times 100. The rank of 77 is 14. Our sample size is 16 multiplied by 100. And so when you put this into your calculator, you should get 82.35 and some more decimal places. And so this will round down to 82. So the percentile rank of 77 is equal to 82. So what this means, the percentile rank of 77 is 82, and that means 82% of the datums in the data set are less than 77. Let me know if you have any questions.